So this is lesson 7.6, which is on linear programming. We've been dealing with systems of equations, systems of inequalities, and now this is kind of like just the real world application of systems of inequalities. So when businesses or economies, they want to involve these different optimization strategies. They'll use this one strategy called linear programming. It helps to find a maximum and or a minimum. So how do we do it? We're just going to basically do what we did in the lesson yesterday on the systems of inequalities, where we are going to sketch the systems of inequalities. We're going to find the vertices. So where do they intersect? And then we have to test the function at each of the vertices and then determine what the solution is, depending upon what we were being asked to find. So looking at this example here, find the maximum and minimum values of this right here. This is going to be basically your optimization function. This is what we want to optimize. So 3x plus 2y. However, the x and the y's are subjected to these various constraints. Okay, so we have to graph each one of these in order to find our area that we're checking. Okay, so here, x is greater than or equal to 0. That here, that is not there. This is x being greater than or equal to 0. So there's that line, and we know that we're going to be dealing with this right side here, right? Everything greater than 0, I'm going to just shade at the end where I have all of my graphs figured out. Y is greater than or equal to 0. That is this line right here. Now, when we're graphing, we want to think about it. It's probably, we could do it as as intercepts. So that works. So I've got 4, and then 2 would be my y-intercept. You could also do it in slope-intercept form if you want to rewrite it in slope-intercept form. And then, of course, we've got one more color. X minus y. So our y-intercept is at -1, and here's at +1. So thinking about where we are going to be shading, where am I looking? So I know that I'm going to be shading to the right of the green line. I'm going to be shading above the blue line. I'm going to shade below the red line. And I'm actually going to be shading above this purple line. So what is my actual area that I'm looking for? It's this in orange right here. This is my area that is including all 3 or all 4 of these lines. And so I've done this first part now. I've graphed that system of inequalities. And now I have to find the vertices. So where are all of the points of intersection of the area that I care about? So here, right here, is one point of intersection, right? That's at 2, 1. Here's another point of intersection, and this is at 0, 2. Here is a third, which is at 0, 0. And then here is a fourth one at 1, 0. So I actually have 4 vertices that I need to check to see where my max and my min occur. So I like to make a table, but you can kind of however you want to organize it. So I'm going to have all of my x and y's there, and then my z, which is a function, or x and y are a function of z. So my x and my y's Let's just list out all of my vertices. I've got 0, 2. I've got 0, 0. I've got 1, 0, and 2, 1. So if I plug in 0, 2 in for Z, I've got 3 times 0 plus 2 times 2, which would give me 4. Then I've got 0, 0. This is pretty straightforward. That's going to be 0. I've got 1, 0. So 3 times 1 plus 2 times 0 gets me 3. And then 2, 1 will give me 3, 2 plus 2, 1 will give me 8. So keeping in mind, I was asked to find the maximum and I was asked to find the minimum. So my maximum is going to occur, my maximum is going to be 8. And that's going to occur when x is 2 and y is 1. So this is my max. And then my minimum is going to occur at 0, 0. And the minimum is going to be 1. Perfect. All right. So in looking here, we're going to do the same thing. The thing about this one, so the reason why I want to go through this example, even though we just did, and I didn't even make you graph it, we're given all the vertices. So we have our x and our y, and then our z. So z is 2x plus 2y. Where are my ordered pairs? 0, 4, 0, 0, 2, 4, 5, 1, and then we've got 5, 0. Okay, so again, I'm going to be finding, that's 8. This is going to be 0. This is 12. So 2, 5 plus 2, 1. This is also 12. And then at 5, 0, we have z is equal to 10. Okay, so I actually have 2 points that are my maximum values, and that's what we are being asked to find. So that means that anywhere along, where's my maximum occur? At 2, 4, and 5, 1, meaning that the line that connects these two, that all of the maximum will occur on this line connecting them. So there's not just those 2 points that are the maximum. Any combination of these ordered pairs that are along this line will be the max values. Okay. So here in this last example, we have like more of a real world problem where we have a candy manufacturer who wants to maximize profit for two different types of candy. A box of chocolate creams yields $1.50 profit per box, and a box of chocolate caramels yields a profit of $2 per box. So that's our optimization right there. What are we trying to optimize? We're trying to optimize profit and maximize our profit. Well, what is our profit? Well, $1.50 for the chocolate creams, right? So I'll say that X is chocolate creams. And then we get $2 for the chocolate caramels, which we will call Y. So that's what I'm trying to optimize. Okay, so that's Z was being used in the other examples, but I want to maximize my profit. So I'm going to call it P. So market tests the following constraints. So taking a look at each one of these constraints. So the first one, so my first constraint is a combined production level should not exceed 1,200 boxes per month. So that means between the creams and the caramels, I cannot make more than $1,200 per month, which means that X plus Y must be less than or equal to 1,200. First constraint, done. Okay. So my second constraint, the demand for a box of caramels is no more than 1/2 the demand for the box of creams. So caramels is Y, remember? So caramels is Y and creams is X. So is no more than. So Y has to be less than or equal to 1/2 X. Okay, now we go on to the third constraint. The production level of a box of creams should be less than, so this is, remember, creams is X, should be less than or equal to 600 boxes plus 3 times the production level of a box of caramels, which is Y. So my third constraint is that X should be less than or equal to 600 boxes plus 3 times the production of the caramels, which is Y. Okay, so those are my 3 constraints, which I need to graph. So that's where I'm going to be graphing here. So I am going to start graphing this first one in red. Okay, so I've got, so I kind of want to think about it as Y is less than or equal to negative X plus 1,200, which means that I'm going to have my x-intercept here. My slope is -1. So here is my first constraint, and I'm going to be shading below it. Okay, so now if I were to graph my green constraint, I know I'm right at the origin. My slope is 1/2. And my Y value says, or since Y is less than, I'm going to be shading below it. So I know based upon these constraints, I'm in this little triangle here. I know I'm not going to be in the negatives. I'm not going to make a negative box of caramels unless I eat too many. And then here, if we are to graph this, I kind of want to think about it in terms of Y. If I were to graph this, so my x-intercept is going to be at 600. So 600. If y is 0, then x is 600. Yep. So, and I've got a slope of, if I were to rewrite this, y is greater than or equal to 1/3 x minus 200. So my slope is -1. I'm sorry, no, positive 1/3. All right, so up 1 over 3 over 3. And y is greater than. So what is my actual area that I'm going to be shading and actually care about is here. So I'm going to do this in this teal. So here is my actual area. And what are my vertices? Okay, so in thinking about this, sometimes we might have to do some systems of equations, which is why this is in this chapter. So I know that I have one vertex here at 0, 0. It looks like this 5, 6. So this one crosses very nicely at 800, 400. I've got this nice vertex here at 600, 0. Now this vertex right here is a little questionable. Not that I can't find it, but just that it's not as easy as all of the other vertices were. Okay, this I'm going to actually have to do systems of equations to find. So this vertex right here, I have to do systems of equations. So I need to look at what lines are intersecting here. Well, the red line and the blue line are intersecting, so I have to do a system of equations of x plus y, and I'm looking for where they intersect, so I'm just going to have that equal 1200, and then I am going to do the same thing for, and I'm going to bring over my blue equation, so I'm going to make that blue. So I've got x is equal to 600 plus 3y, and I could just do substitution here. It lends itself very nicely. So I've got 600 plus 3y plus y is equal to 1200. Combine like terms. This is 4y is equal to 600. So my y value is 150, which means I'm going to be selling 150 caramels. And what is x? Is 600 plus 3 times 150. So 600 plus 3 times 150 is 1050. That would have been a really hard vertex to find just by eyeballing it on our graph. So what is that vertex? 1050 and 150. All right, now that we've found all of our vertices, now we have to go ahead and actually optimize and find the maximum. Which one of these combinations is going to give us our maximum profit? So I'm going to make my table. I'm going to make my max profit, right, with my optimization equation, which was 1.5x plus 2y. All right, so what are my vertices? Well, I know that 0, 0 is going to give me a profit of 0, so not ideal. All right, what was another one? 600, 0. So I'm going to get 1. So I'm not going to be selling any caramels here is what this is saying. Okay, so we get 900 here. That's good, not great. Let's see what else we've got. We're going to try the 1050 and 150. So my profit plus 2 times 150. So my profit at this point would be $1,875. So better, getting better. And now let's check the last one at 800, 400. So when we calculate that, 100 plus 2, we get 2,000. So what did we learn? What did we decide on? What did this information tell us? Well, this candy company, they should sell or produce. They should produce. And my computer is lagging. 800 of the creams, of the chocolate creams, and 400 caramels to make a profit of $2,000. I hope that you found this, you were able to understand this lesson. I know this is like more of a real world application, but I will see you guys on Monday. Have a good weekend.